Graphs. We're going to talk about the three main ones, sine, cosine, and tangent. And you're going to see that now that you know the unit circle, it's going to be easy peasy. So we really, the only thing you've done with it so far is graph it and do like domain, range, what maxes, min, zeros, and that kind of thing. All right, let's start with sine. Whoa. I know. All right, I'm going to set up my trig graph. And by the way, your trig graphs will always, you know how if you do zoom 7 on your calculator, or maybe y'all didn't, zoom 7 is zoom trig, it runs you, whereas a standard window goes from -10 to 10, a zoom trig will take you out -2 pi to 2 pi and -1 to 1. And then every tick mark is going to be a half a pi. So we'll just stick with that here. This is the little chart, yeah. I like your haircut, Brian. Did you get a mall cut or just one? Thank you, I appreciate that, y'all. Okay, I'll be here all day. Well, only until 3:30. All right, tell me what is the sign of 0 and think unit circle. Zero. Sign is the y value, so it's 0 is 0. So we have 0, 0. What is the sign of pi over 2? So now I'm clicking up 1. It's 1. So for these, if you look on your unit circle, I'm just clicking every quadrant, right? 90 degrees up. Yeah, so just go over 2. How about pi? 0. How about 3 pi over 2? Close. -1. And at 2 pi, I'm back around where I started, which was 0. And I could even fill out the rest of these because it's symmetrical, right? So I'm going down, 0, up, 0. So you can catch the curve. Oh, I remember this. Does that make sense? Do you see how we got the points? Yeah. What's wrong, Christina? What's wrong? So yours goes by quarter pi, so go two places over to make a half a pi. So yours has marks like this. If that's what you were asking. It's good. We didn't do much, but it was good. We went to the farm, that little animal place. How was yours? It goes so fast. I don't know why school weeks don't go that fast, but when you're home, it just... All right. Everybody good on the graph itself? Yes, we're good. Okay, good. How about the domain? Easy peasy, right? How about the range? That's right. Inclusive or exclusive? Inclusive, because it can be those points, right? So I'm going from -1 to 1. What are my x-intercepts? So you do that little thingy thing, right? That little weird thingy thing. So I'm going to say x equals k times pi, and it's happening every pi, right? So I'm going to say where k is an integer. Remember that? Remember when we did that? That's like, yeah, it was like a C with a line through it. It says k is a member of the integer family. So it means the x-intercepts are happening at every, if you take any integer in the world and times it by pi, that's where my x-intercepts are happening. So 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, and so on. Or negative pi. Does that make sense? Madison, you good? So this is saying I could plug anything in for k that I wanted as long as what I plug in is an integer. And those are going to be my x-intercepts. Every pi, yes. Every whole number pi, essentially. The y-intercept is 0. That's easy, right? That's 0, 0. What else do we have? Asymptotes. Yeah, none. Right? No asymptotes here. There's no place where I'm undefined. Now here's something new. This you may not have. Have y'all learned about amplitude and period? No, because I would have touched it. 0. All right, so amplitude, and if you want to write this somewhere you can, you don't necessarily have to. Amplitude is essentially the height of the graph. Amplitude. And this is how I think about it, the height. So it's the height whenever it's centered here. I take the lowest point and the highest point, find the difference, but then I divide it by 2 because see the height's only really going to here. But none. So the amplitude on this would just be 1. It's how high the graph is. That's what it describes. So really it's the max minus min divided by 2. Because height, it is height, but it's height whenever it's in standard position here and it hasn't shifted. Yeah. 2 over 2 is 1, right? I'll try. No, I'm just kidding. No, this is not my favorite. I like the trig graphs, but I don't like the period and the amplitude analysis. All right. Period of the graph. Period is how often or how frequency is 1 over period. Let's say how long it takes to make one full cycle. Because we see this starts repeating, right? We already said it was 0, 1, 0, negative 1, 0, and it starts this pattern. How long does it take it before it starts repeating the pattern? And think about on the unit circle. From what? Close. If I start here, if I start at 0, how long does it take me to get back to 0 while the graph is going up? 2 pi. And then the pattern starts repeating again, right? Because it's 0 up, 0 down, 0, and then it repeats again. 0 up, 0 down, 0, repeat. 0 up, 0 down, 0, repeat. Right? Are y'all following me? So the period on this is 2 pi. And if you think about it in terms of the circle, it makes sense because you loop all the way around the circle and then everything just starts back again and back again and back again. For the parent graph, yes. On the graph or on the circle? On the graph. So, all right. You have to recognize first that this 0 and this 0 are different, right? Because it's not repeating there. This is a 0 when the graph is going up. This is a 0 when the graph is going down. So how long does it take me to get back to the point with the 0 going up? Well, 0, up, 0, down, 0, and here I am going back up. So from here to here is one full cycle of the graph. From here, I could cut that and just keep pasting it and putting it over and over. So it's 2 pi is how long it takes to make one full cycle through. Yes. That span from 0 to 2 pi. But anywhere on the graph, if I go 2 pi, like if I went from negative pi to pi, that's still one full circle, one full cycle. I could cut that and keep putting it. That's how long it takes it to repeat itself. Does that make sense? If I fast forward 2 pi at any point on the graph, I'm going to end up back at the same height I am. Are y'all good? All right. The rest of them should be easy now that you understand that. All right, you got a place that says transformation. So just like where we transform any function, we're going to transform these. So what does the equation look like that we're going to be transforming? Well, I'm glad you asked. Yes, this goes in the transformation box. Yep. So for these, we kind of have, but now we're going to use some trig terminology. A has to do with my vertical shrinks and stretches, right? Well, what did we just talk about deals with this? Amplitude. So the absolute value of my A is going to be my amplitude of my graph. Y'all okay? Remember, the negative is just going to be a reflection. It's not going to have anything to do with it. That's why I say absolute value. My period is going to have to do with horizontal shrinks and stretches, and that's going to be my B because that's going to be, right, how often it repeats itself. So I'm going to take, what I'm going to do is I'm going to say it starts out being 2 pi, but what I'm going to do is divide it by the absolute value of B to find my period. Your period of your regular is 2 pi, but to find if I've transformed it, if there's a number here in front of x, that's going to be 2 pi over, that's going to be my period. Absolute value here is going to be my amplitude. And remember, I'm doing the absolute value because the negative is just going to either reflect it this way or this way. Everybody okay? All right. Horizontal shifts and vertical shifts are exactly the same as what they were. H and K do that, as they always have. Horizontal shift, again, opposite sign, right? And vertical shift. Same as it's always been. So if it was 2 sine, yeah, it slipped on me. That's right. This would be left 1, down 3. Yeah. Yeah. And we'll come back and do some full-on analysis with them. I just want to get you the information out there. All right. Huh? Yes. Right. Y'all ready for cosine? If you're not, ooh, don't sip her drink. Did he say, can I have a sip? Oh, I thought he said, can I have just one sip out of your drink? What? Bro, what are you talking about? I don't know. Okay, ready to cosine. So cosine, it's like a shift, actually. And so it's nice. If you understand sine, cosine should be a breeze. We'll set up my exact same. I hope this makes a little more sense now that you've done unit circle than it did the first time you saw it. Because y'all were quite confuzzled the first time we did it. And maybe I should just wait until now to start showing it. Oh, yeah. Oh, yeah. All right, here we go. What is the cosine of 0? Back on the unit circle. At 0. At 0, what is cosine? 1. That's my x value, right? If I'm on my unit circle, this point is 1, 0, so the cosine of 0 would be 1. Yes? Yellow, okay. So, no, this point at 0 is 1, 0, right? The y is 0, but the x is 1. What's this point right here? And so I've got cosine, sine. So the cosine of 0, so go to 0, and what's the x coordinate? It is. Where's your unit circle? Pull out your yellow unit circle. Not where x is 0. This is saying 0 degrees or 0 radians, right? So whenever I go to pi over 2, now I'm at this point. Now my cosine is 0. You following me now? Okay. It's just been a little while. It's okay. It's a long break. All right. So the cosine of pi over 2, so now I'm clicked up at the very top. The cosine there would be 0. Then if I click over to pi, the cosine there would be -1. And you have enough now that you can probably pick up this pattern. At least I hope you can. Someone just fill in. Ooh, that was kind of close together. That's terrible. What do you mean? Go to pi over 2 on your graph. Where's pi over 2? At the top. What's the x coordinate at pi over 2? 0. That's what I'm saying. Oh, that's why. Oh, sorry. Oh, okay. I thought. Right. No, you didn't. That was on me, and I even drew it and was like, oh, why is it not going together? Okay. Much better. Sorry. Right. My bad. All right, what's the domain? What's the range? Exactly the same. X-intercepts. Ooh. It's like where it's not an integer. This one is an integer, but it's a little bit. It's still happening every pi, but I'm not starting. I'm starting at it's a fraction, right? How could I write that? Where it's like the integer sign over like a number. Okay, you said the integer sign. Well, let's call it k. Yeah. Oh, okay. So k is an integer, but how am I going to define it? X equals what? Okay, so Brooke, let's see if it works. K, don't write this yet. K pi over 2. So at 1 pi over 2, at 2 pi over 2, at 3 pi over 2, is that what's happening? No, because look, at pi, which would be 2 pi over 2, it's not there. So that's not going to work. But it's really close. Okay, at pi over 2, you're getting there. If I start at pi over 2, you're close. How long does it take to get to the next one? How much space is between here and here? This is half a pi. This is half a pi. Pi. Is there always pi space between it? So why don't I say plus k pi's? That would keep me over, right? That's saying start at a half a pi, add 1 pi to it. Where do you end up? Add 2 pi's to it. 1, 2. It should be crossing there. 1, 2 here. 1, 2 here. Does that make sense? Unless I start stretching them. I'll let you get started easy first.
Like the first one I got, but that one I don't get why it's that. I don't get why it's that. Like I get that it means like it's too high.
So you get that the space between each one is pi. This one's just different because it's not happening on whole pies, it's happening on half pies. I could have described the other one as pi plus k pi. But really, there wasn't any need to do that. That's saying I can plug any integer I want in for k. I could plug in -2, -1, 0, 1, 2, 3. We'll keep practicing with it. Don't get flustered with this if you don't understand the k quite yet. All right. Y'all okay?
I'm laughing at pi.
This is the x-intercepts. What's the y-intercept? 1 or 0? Which one? 1. 1. Asymptotes? None. How about the amplitude? Oh. Yes. Amplitude is 1. Amplitude is the same. How about the period? 2 pi. It's still 2 pi. Look, it's still the same graph. It's just shifted over, right? That's all it's done. The amplitude is the same. All of that is exactly the same. 2 pi. All right, well, then let's start. It doesn't matter where you start. You can start anywhere you want. At any point on the graph. Okay, so let's say I start right here. How long does it take me to get back to the top of a mountain?
Oh, I like that.
Well, easier to see that way. And then it would start repeating the pattern. Right. That distance is 2 pi. But you could do it from anything you wanted. If I want to go from this 0 to this 0, that distance is still 2 pi. Right? Because each dash is a half. A half, a whole, 1 1/2, 2. You have extra tick marks in here. They're each a 1/4 pi.
Oh, I just skipped one.
Yeah. What do you mean? So if I go from here to here, how far is that horizontally? How did you label yours? That's right. That's right. Erin, will you point to her graph and show her the 2 pi? The 2 pi, how it takes to 2 pi on her. The period, yeah. You know what I'm saying? She doesn't understand how the tick marks are working.
Oh. This is like a half.
It's a half of a pi. So a half of a pi. So every other one makes a half. A half and a half is a whole. Another half makes 1 1/2. And then one more half gives you 2. All right, how about the amplitude? Oh, we already did that. We did period. Okay, let me give you the transformation form. It looks exactly the same. Everything does exactly the same, so just transfer your information from the first one over to the middle. No, that's a different thing. The thing before break was law of sines and cosines. You're welcome.
Okay, so wait, I'm right.
None. None.
We finished the homework too. Go pop quiz while you're gone. For the B, do we like actually write out the
Yes. Okay. And then, but that's a general form, so I'll show you with some examples how we'll do it.
Is it all the same stuff like?
Yep. Transferred all over. All right, y'all ready for tangent? It's the most fun. Nope. Tangent's different. Tangent's always different.
I hate it.
Whoa.
What the heck is that?
Tell me what's special about tangent. Specifically about the unit circle, what's special? Okay, but again, think about yes, but think sine over cosine. But think about the points that we're talking about, the half pies, every half pi. What's happening to the tangents? Okay, go back to what? What'd you say? Undefined. Look at the points that I'm talking. Okay, so where on your unit circle is tangent undefined? Pi over 2. Do we all agree? Pi over 2, tangent is undefined. It's an asymptote. In fact, everywhere tangent is undefined on your unit circle is a vertical asymptote. Look at your unit circle. Where all is tangent undefined? Tangent's undefined everywhere cosine is 0 because you can't divide by 0. And my pattern is going to start repeating. All right. I'm going to show you. I shall show you. All right. Let's look at the inside here and let's reason through this, okay? What is the tangent of 0? Look at 0 on your circle. What's the tangent? It's 0. Now,
And how do you figure that out?
sine over cosine.
You look at the unit circle. So 0 divided by 1.
Yes. So it's 0 everywhere sine is 1 is 0. If this is 0, it makes it undefined when cosine 0. Okay. All right. So now my question to you is, because these will be non-calculator. Okay. So my question to you would be, as you move on your circle, look at your circle. As you move from 0 to pi over 2, do the tangent values get bigger or smaller? You sure about that?
But it goes to undefined. That's very small.
All right, look. Let me draw this for you. Just from here to here, okay? So I'm at 0, I'm 0, right? What's the tangent value here? What's the tangent value here? I know this is. What's the tangent value here? Are the numbers getting bigger or smaller? They're getting bigger. Well, I'm dividing it by 3 here, okay? So they're getting bigger. So that means here, as I'm getting closer and closer to this undefined, it's getting bigger. So it's going to do this and hug it, which means it's got to go the other direction. That's how I reason through how to draw this, okay? I'm not making you find any of the in-between points because it would be, I mean, you could technically do pi over 4 at 1, right? So mine is way off, though, if I'm doing, let me see. And so now I'd pick up, here's, it. Now it starts to repeat, and I'm going to start doing all the same. And it's just going to keep on with the same pattern. Yeah. All right. And it continues on. Yeah. So the domain is a little funky. What's making the domain a little funky, Zoe? Yes. There's an infinite number of asymptotes, right? Well, we're going to do it kind of the same way we did x-intercepts. Okay, so here's where, put on your big boy and girl undies. All right, the asymptotes. Tell me before I do it, before I write it in math terms, tell me visually what you see is happening for the asymptotes. Is it every half pi? They're pi apart, but it starts at a half a pi, right? I know what you're saying. I know what you're saying. Okay. All right. So it's going to do the same as what the x-intercepts did on the last one, right? On the cosine graph. So for my domain, those are the only points I have to leave out, right? So I'm going to say, I'm going to say x cannot be. Okay. Instead of, well, because to leave it out, we could do interval notation and we could say from here to here. If I did an interval notation, it'd look something like this. Dot, 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 u. Negative pi over 2 to pi over 2. U. No, I'm saying if you did it in interval notation, but generally, interval notation is the easiest to use most of the time. But whenever I get to something like this, we kind of don't use it anymore because it's too hard to show. It's not quite as... So instead, I just say what all x can't be. And I'm going to do it kind of the same way that I did it with those x-intercepts. I'm going to say x can't be pi over 2 plus k pi, you're exactly right, and k is an integer. Wouldn't be wrong. Just be able to, I eventually want you to be able to get to this. I'm listening.
And pi over 2, that is like half a pi.
Yes.
So then from 0 to pi, and I'm trying to think like.
Okay, so because I'm trying to make it to the other asymptote, not just, so you're going from here to an asymptote, but I want to go from asymptote to asymptote. So how far are the asymptotes apart? Well, all together, that's a half a pi, but there's 2 of them. So they're actually a whole pi in between. So if I start at half a pi, what's half plus 1? What's a half plus 1? 1/2 plus 1. Right? So I'd be here. Then if I add another pi, I'm not here, but here, and that's where my other asymptote is. It's just offsetting them is what, instead of k pi, it's pi over 2 plus k pi. They're still pi apart, but they're offset. They're not an even number apart, if that makes sense. Yes. And you can always do that. You can do starting point plus how far apart they all are. All right. Whew, range. Negative infinity. Thank the Lord. Here we go again. How about the x-intercepts? 0. Is that the only one? It's on every pi. This is an easy one. You could do k pi. You're exactly right. Look at you go, Zoe. X-intercepts. K pi. K is an integer. Take a shot in the dark. What's the amplitude?
Infinity.
It's undefined. Oh, 0, sorry. Y-intercept is 0. Amplitude is undefined because it's going up forever and down forever. I can't get a max and I can't get a min. It doesn't have one to give, so it's just undefined. There is no amplitude. Tangent doesn't have. Oh, I forgot that too. Instead of x does not equal, it's x does equal for your asymptotes. Yeah. Because this is telling you what x can't be, and it's leaving out the asymptotes. So the asymptotes are just going to be x equals, and I'm going to pull that same equation. I got way ahead of myself on that one. Period's a little bit different on this one. It's 1 pi. That's exactly right. Why is it 1 pi? It's a little bit easier to see on tangent. This is pi. This is pi. This is pi. In fact, it repeats every pi, so your period is pi. Everybody okay? Okay. Yeah, asymptotes are the domain. It's the domain, but it equals instead of does not equal. Okay. Transformation is very close to the same. The only thing that's going to change your ant does not exist here, right? And your period, instead of 2 pi over b, it's pi over b. Because it's
out all the way. Are we supposed to do that, or do
what do you mean?
I've been making all things instead of just putting it in the box. I was like, what did I do last time? I said 1 cosine 2 pi over b value x minus and else.
Oh no, you're doing too much. Yeah, you're doing way too much.
That's why I was like,
It can still shrink or stretch it, right? But it's not. It doesn't have an amp.
and then horizontal and vertical.
Same thing. Same thing as it was before. Copy all that information. The H is your horizontal, the K is your vertical. Because I can still shift these. I can still slide them left and right and up and down. The asymptotes are sliding with them left and right. Up and down aren't going to impact your asymptotes, but right. This is right, left. This is up, down. So horizontal shifts would be H. If H is positive, then I'm moving to the, I guess you'd want the opposite signs. So left, negative H would be right. All right, y'all ready to do one? Kind of a loaded lesson coming back, right? You want to take a breath? Want to take a breath for a minute before we do an example? Okay. Yeah, all you're doing is amp, period, and then sketching a graph here. No, you have your point, silly goose. All right, let's look. Silly goose. We'll do, would you say 4 or 5? All right. You can, but you have to show your work. I'll show you. But I did say some of these are, yeah, non-calculator. I know. All right, let's talk about what's happening as this compared to the parent graph. So first of all, the amplitude is different, right? But instead of thinking for trig functions, instead of thinking about as stretches and shrinks, I'm going to think about them in terms of amplitude and period. So what's the amplitude? 2. And if you think about this, because I don't have any shifts left or right or up or down, it's going to make the graphs of these a lot easier. So I'm still going to be centered where I was. That's just where I'm stretching and shrinking from. Are y'all okay? All right, so the amplitude is 2, and the period. All right, so how do you find it? 2 pi over b. So 2 pi divided by 8/3. So what I'm going to do is I'm going to multiply by the reciprocal here, right? Whoa. So I'm going to do 2 pi, that's exactly right, times 3 over 8. 100%. Okay, yeah, don't do that if you don't understand that. Did you say let's not do that? Oh. I'm hearing things today clearly. I think I was on my ear. All right, so what does that mean? That means that now my graph is stretching up to 2 and down to 2, right? Because I haven't shifted. And now it's going to repeat every 3 pi over 4. So let's think about what that looks like. Cosine starts out. So instead of, correct. Because the height is 2. Took me a minute, sorry. Now this is where the way yours is labeled, it's probably a little bit easier to see because you have the ones in between here, right? And if each one of those is a quarter pi, this would be pi over 4, 3 pi over 4. Are you confused? Okay. So what this says is, to be back at this very top point, right, I need to go over 3 pi over 4, which happens right here. 1, 2, 3 over on yours. And that's going to put me back up here. Now, halfway in between, right, halfway in between these two, it should be at -2. So, and you may have to kind of estimate on some of these, but I know I'm going to be down at -2, halfway in between. It's not going to be quite, right, 1, 2, 3. So I got to go halfway between 3 of these would be 1.5, right? 1.5. It's going to be about right here. Right, because look, there's 1, 2, 3 spaces that are all equidistant. So halfway between 3 would be 1.5. Okay, so what about the other 2 ones? Now they're going to be halfway in between these 2. Right? So halfway in between these 2, that gives me 1.25. What's half of 1.25? Just a little past 1, right? No. Almost to 1. Almost to 1. It doesn't have to be exact on here. Yes. I would just, so here, about right here, and then same thing on the other side, right? Because that's what happens when your period gets, the smaller your period gets, the more it shrinks. And it makes sense because 8/3 would be a horizontal shrink because it does opposite, right? So it's just smushing it in like an accordion. Well, no, not 3 pi/4, a little after pi/2. And so what is this doing? And I'm going to get enough to do 1 period here so you can kind of see. And then I would kind of follow this same bless you. Okay, what's confusing? Okay, so I needed to get it between, think about this, my period needs to be within this area. I need to get through a whole loop, right? So I went over from this point up top, which I knew where to start. I knew my starting point. I needed to get over to 3 pi/4. Well, to find out where the bottom point is there, right, then I need to go halfway between those two. So that's why I started kind of dividing it up. The 1/2? What 1/2 are you looking up? Oh, well, halfway between 0 and 3 pi/4, right? And that's where I got halfway between these two. This is about halfway through those two. And then I needed to make it halfway between these two, which was about right there, to find the 0. So you're constantly cutting in half, essentially. I want to make sure you got enough to practice. Let's do a stretched out one. Let's do number either 10 or 12. 12. All right, 12's got a reflection in it also, so be very careful. The reflection, see that reflection in the front? It's reflected. That tells me instead of the tangent going like this, it's going the other way. That's right. It's going to be doing this. So keep that in mind as we go through this. All right, so we've got f of x equals -3/2 tan 1/2 x. Again, I don't have an amplitude on tangent, right? All right, so amplitude is none or undefined or does not exist. Any of the above are fine. Period pi/1/2, which would be pi, so it's 2 pi. So now everything is stretched out. It's twice as wide now. Does that make sense? So originally, exactly. Originally, my period was pi. Now my period is going to be 2 pi, which means this is going to go out to pi, and this is going to go out to -pi for my asymptotes. Do you see why? It's not shifted left or right, it's just stretched. That's all that's being done. They've shifted out because my period has changed. My period is now 2 pi instead of 1 pi. So instead of it taking 1 pi to get from one to the other, it should take 2 pi. So to get that stretch out, I have to go out and make 2 pi. Right, right. Because 2 pi's make a 2 pi. Right. Now I need the points in between, which can be a little bit harder. Well, and I'm going to tell you, we'll just do this the easy way for finding the first one, since we don't have any shrinks or stretches. We'll put our asymptote here, asymptote here, 0, 0. I'm going to do this very first point like a slope, and I'm going to go, I hate doing that because we're not going by. Pi is 3.14. So I'm going to go over about pi and down 1, 2. Yeah.
Okay. Oh, but what about negative 3
I feel like negative 3 1 2. But pi is 3.14. So she made it close to
Right.
3.
Let's just hug them towards the asymptote in the way that they need to go. And just understand how the stretching and shrinking is before, and then we'll talk more tomorrow. I don't want to throw any more on you today other than this, but we'll get a lot heavier into transformations later on this week. But let's just say I know it's reflected and I know it's going to hug towards the asymptote, so let's just hug it in that direction. And that'll be good enough for now. Fair enough?